All right. Well, it's great to see such a big group for maybe a more niche topic than we usually do about teaching advanced topics, and specifically around sort of C++, C, and assembly autograding. So to quickly introduce myself, my name is Yuri. I'm CEO at Autograde. We also have some of our other staff in this call. So if you have any complicated questions at the end, I'm sure we can answer those. But for today, quickly about sort of what we recently released and what's coming up, just to give you a bit of an update of what we've been working on, and specifically our product team. And then we'll just jump into sort of talking about auto grading for C, C++, and assembly. And we'll start simple, and then we'll go to like using things like Google Test and doing x86 assembly. Also, we'll touch on things like checking for memory leaks with Valgrind. And then we'll have plenty of time for Q&A at the end as well. As we're not a super big group, feel free to put in questions in the chat during the call, and then I'll try my best to sort of answer those while we're at it. But without further ado, let's first talk a little bit about sort of what we've been up to in the past month or so since we did our last webinar, sort of at the beginning of August. And of course, I hope you all have a great start, or had a great start to your academic years, and I hope it was without too much trouble. But I think you're all still pretty much in the thick of it, so you're making time for us today. So within the past month, we've released quite a few improvements to Autograde, and I'll also show these sort of live to sort of see what these look like. We've been working a bit on exams, and also working together with customers on what they need here. And the first of these features is IP access restrictions. So Tilo, who's in this call, helped us a lot with this. So I hope you will enjoy this. I'll show you how that works, but it's great for using Autograde in sort of for in-person exams, where you want to make sure that all students are coming from the same IP, especially if you're using like exam devices, like maybe Chromebooks or computers. Another feature we just released, also based on some customer feedback, is the ability to download files from the editor. So of course you set these editor templates, and then sometimes students don't want to work from this editor, or they want to continue in like VS Code or something. So we've made it easier to just download files from there directly. If you're using the coding questions and specifically the quizzes feature within Autograde, and you want to use this more formatively, we've added two features that might be of use to you. The first one is simply to be able to reset the question back to the template. So if students accidentally mess up, they can simply reset and start over. And another one is the ability to give students the possibility, what a sentence, to show the solution within the editor, and I'll show you that in a second. And then finally, a couple of quality of life improvements. So we've added a create assignment button on the course home, and we have added a permission, so if you're using the AI, to hide that system prompt from students. So let me show you some of these features live, so that hopefully it's a bit more speaks a bit more to mind. So back into Autograde here, and you see I'm in a course. I'm currently a teacher. This is my teacher account. And if I go to the settings for a specific assignment, you will see in the right, there's a new tab here called Access. And if I go in here, I can set IP restrictions for this specific assignment. And here you can add a IPv4 address or like a range. And then basically students can only access it from those IP addresses. So if I find my IP and then put this in here, and I could do something like this. So if I want to add like a range, I can just add this. And now if I go into the student view, you will see I can access it. That's great. If I leave the student view and then I go back to the settings and I do something like this and save this and then go to the student view, you see I don't have the permission. So I'm sort of locked out of this assignment. So this is, again, great if you use CodeGrade in sort of in-person exams and things like that, or even in like in-person labs where you want to make sure that students are in the actual room to access it. And again, if you don't want to use it, so you just delete the rule. If there's no rules, you can access it from everywhere. So I'm looking forward to see what people will do with this. Next, so let me go into the submission. So let me go back into the student view here and then go ahead and submission. And you will see that we have a bit of a new UI here. That's sort of in our new UI pattern for the coding question. So you see the check your answer button is now more pretty. But also, if I go to a coding question, and for this I've configured that students can see the solution. You see there's an actions menu now where I can like reset. So if I make, so let's say I made a mistake, I can reset my answer completely. And now we're back to sort of the state that the question started in. And of course, I can undo this if I want. So if I made a mistake, then that's fine. I can redo. And then finally, there's also a reveal solution. Which I can do, and then what you will see is we can see the reference solution right here that's being configured for this assignment. So this is, again, really nice if you formative assignments. If you use this for like exams, maybe not a great idea to give students access to the reference solution. How to configure this is really quite easy. So if I go out of the student view, and then go to the settings for this quiz, and then go to auto test, because auto test is where you configure all of these quizzes. And then I go to question 3. There's basically a new box solution. If you just leave this empty, there's no reveal solution because there is no solution. And otherwise, if you fill this in there, the button will appear. So if you don't do anything, the button won't be available. Finally, I will quickly showcase. So if I go back here, there's a create assignment button, relevant if you don't use CodeGrade with the learning management system. And then also let me go into a solution here. And then now you have a download button here for files in the editor. So that's sort of all of that we've done. It's quite a lot over the past month. So let me go back and sort of talk to you about what we're working on for a couple of weeks or the next while. And also, you will see like we have a new roadmap available as well. So that's sort of integrated with our product development process. So if you want to take a look at what we're doing or what we've done, you can go to codegrade.com/roadmap. What's coming up? We have a couple of items that came up sort of from our new UI that we're sort of bringing back or that we were improving. So one is a grading status column in the submissions list. So if you use manual grading, you can see which students still need to be graded. This was highly requested, and that's coming very soon, I think. And then also a one-click action to move to the next ungraded student from the submission overview. So if you're grading a specific student, you're done with that, you can press a button and go to the next student. So you can really easily manually grade all of these. Finally, related to our sort of exam improvements, we're adding password protection for assignments. So if you do, again, some sort of like in-person exam or like a proctored exam, you can set like a password on the CodeGrade assignment. You only give that password through the proctored environment, and then students exit it through there. And then we're doing some small improvements related to things like accessibility and the new UI. So adding sort of new forms and things like that just make everything a bit nicer. And then finally, so this is sort of what we're working on now, so you can expect these all in the sort of next few weeks. And then later on, sort of in the next few months, we're working on improvements to the AI assistant within CodeGrade. that's making it context aware. So think like being able to see the question statement, the code that the student writes, the auto test results, and some other things that we'll share with you soon. All right, so that's sort of what we've been up to. So let's get into the actual webinar portion now. So let me share my screen again. All right, so let's first start with a simple C assignment. So let me go into this one. So here I have the example often used, which is just a simple Fibonacci assignment, which sort of makes it easy to explain a couple of things about autograding itself, and then afterwards we'll make it more difficult. So this is an assignment I've set up, and here you can see students will just do everything in the main function, and it's quite a simple assignment. And then the auto test is also pretty simple. So we simply just have compilation. We are using input-output testing, code structure testing, and then we added in just there's no memory leaks here, but just how you can do Autograding as well. So the moment students submit it, they will see this, and they will be able to see what passes and fails. So let's make a mistake here. So let's start with 1-1. And of course, I can run this in the editor. Oh, I am on a test instance, so give me a second. Oh, there we go. All right, so now you can see that the IO tests are failing because the actual output is 11235 instead of 01123. So I can easily fix that. Of course, like code structure tests, they still pass, and compilation still passes. So let's move into sort of how you can set these things up. So from the submission overview here, I can go to the assignment settings, and this is sort of where I set everything up. So this is where I can set the allowed submit methods, the schedule, all of those things. But of course, what we're interested in is the auto test, which is right here under auto test. And auto test has two stages. We have the setup phase and the test phase. And in the setup phase, we install any software we might need. So what you see here is specifically for C and C++, we have two installation blocks. So you can choose between GCC and Clang. For this specific assignment, we've chosen GCC. So I add a install GCC block. And then also I want to install Valgrind. So for that, we use the script block. The script block really is just any sort of that script that you can do where you can install software. So you see we just do an apt update, and then we do install Valgrind, and then we'll just install everything. And this is also sort of the place where you would install any other packages. So when we move to the Google Test assignment in a second, you will see we'll do some installation of Google Test here. Autotest runs on virtual machines, and they run Ubuntu. And every student has access to 4 gigs of RAM and 1 core by default. So, and in this setup phase, what happens is this runs once. Then we create an image of that, and the moment student presses hand in or they press that run button in the editor, it starts from the state, it restores that image. So this can all take a long time. For students, it will still run instantly. So that's why you do all your installation here. Also important to note, this is where by default you have access to the internet. So any command you run has access to the internet, which is handy if you want to do installation. Also, I think this has a limit of at least like 30 minutes or so to run. So if you really want to do some heavy installation, you can do that by default. Then when I make any update in here, I can simply press build snapshot here, and you will see sort of what happens. So you will see the setup starts running here. I made an edit here, so you will see actually GCC and Valgrind are sort of cached, so that sort of runs instantly. And then it's doing some installation automatically of the code structure test that we're using. And then once this finishes, what you will see is, give it a second. Of course, this takes about a minute usually. But this illustrates the fact that you want to do things in the installation, right? We don't want students to wait like a minute every time. But while we're waiting on that, we can go to the actual tests. And you can just back out of this, and you can always open it back up. You don't have to wait here. And here you can see we have our actual test. And again, so for things like Java and Python, we have quite a few blocks built in. But for languages like C, C++, the use cases are usually much more varied. So at the moment we have less blocks for that. So sort of your script block tends to be your best friend. So for compilation, for instance, we're just running GCC, we're turning on warnings, and then just making an executable. Of course, if students use things like make, you can, and they have a make file, you can just run make here, and it all works. This really just behaves like your terminal. And then after that, we will have a executable called Fibonacci. So then when you see here, when we're running our input-output tests, we can simply execute Fibonacci, we give an input, and we have an expected output. And we have 3 different options for that we use. We have a full match, so we need to exactly match this expected output. We have a substring match, and then regular expressions. And these are Python rejexes. You can use that. And then finally, for the code structure stuff, and I'm going through this a bit fast because this is still the simple, so we have some more time to go into the more advanced things. Code structure, we're matching a specific pattern. So here we're matching like a if statement sort of pattern. And these are semgrep. We're using semgrep in the background. And if you go to their website, there should be a playground. There we go. And you can sort of play around with these, and then you just copy paste it back in, and it will just work. And these are really nice. So semgrep stands for semantic grep, so it grabs through code, but not based on like the text, but based on the sort of abstract syntax tree. And then finally, because we've installed Valgrind, we can use a script block and just run our regular Valgrind commands, which does your leak check. And then we just have to make sure that we set the error exit code to something on 0. And the script block will always fail when the exit code of the last command it executes is not 0. So if I were to do something like this here, then it will not be 0 and this will fail. So that's sort of the easy way of sort of how the script block behaves. So it's important to know, like if you have a program where you expect students to have a non-zero exit code, then of course you have to do some bash here to rewrite that to a 0 exit code. And the same goes for the input-output test. So the input-output test will fail in 2 conditions. One, if the output doesn't match the expected output, but the other one is if the program here doesn't exit with 0. And that's of course because typically that means the student program crashes in some way. Maybe it gave the right output, but it crashes. You can always do something like this to always make the exit code correct. Or you can do like a bash one-liner here to rewrite the exit code. So if you're expecting 1, make the 1 a 0, and otherwise exit something non-zero, if that makes sense. Again, so this should be done now. Yeah, so you see we're running now our student, and of course we modified the student code, so these will still fail, and this automatically runs on our test submission. So I can open it up. So that's this test student. This is what all the tests will test on. And I can always add a new submission here by add submission. I can upload my file, select test submission, and I can upload a new new test submission for this. And then once I build it, and then I said publish to student, it will automatically rerun on all previous latest submissions. And of course, for students that are working on it, they will get the latest version. You can also always, if you click on this, you can sort of see what you've published. And then you can go through the test and the setup that you've published. And then you can always unpublish from here as well. And then it will delete it, and then it won't be available to students. So if I go back to the auto test configuration, you will see there's no published snapshot. All right, so a couple of questions we had in the meantime. How do I hide solutions until the deadline? I guess that is about the earlier feature. That is something that's not possible yet. But we will work on some hide options for in the future to make that possible. And then Tilo, why install GCC? Isn't it there by default? That's a good point. So GCC is there by default. But if you want a specific version other than the default, of course, like Ubuntu ships with GCC, then you would use the install GCC block. I'm not quite sure what the currently default installed version is, but if you want to manage that specifically, you would use the block. And same goes for Clang. I'm not sure if that is there by default, but anyway, it's probably best practice to just if you use any of these versions to select it by default. All right, so let's move on to C++. So I have sort of a concurrency version of C++. A quick question, which Ubuntu is it? I think it's the 22 LTS version. And yeah, it would be great if we can add some new versions of GCC. So we'll definitely add a feature request for that to make that, to add these options to the list. Of course, if you want to do like custom versions, you can always just use the script block as well. But yeah, it's a little bit more difficult. So yeah, the C++ concurrency assignment. So they have to do like create like a bounded blocking queue using the C++ standard library. That's thread safe. So we have like an assignment here where students have to, implement basically a header file that's going to be this class. And if I go to the submission list and then the test student, you will see we have a specific directory structure that students will use. So that's also something that we will often see with more complicated assignments. You want students to work in a sort of a pattern. So students here start with a CMake list, so a CMake file. And then they have a source file where their blocking queue is in. Let me understand this a bit slow. All right, and this is where they will write their solution in, and they sort of get a template for this. And then what we also provide them here is already some basic tests that they can run with CMake. And then what we will do in the auto test is we actually replace all of these tests with our own tests that you can see here. So besides these 3 basic tests, we add in some other tests, and this is all using Google Test. And we run those basically with the auto test. And we also modify the CMake file to add in those other tests. Students will work through this assignment either by using the upload files functionality. So if we go into the student view here, we will either upload files. They could use the editor, but maybe in an assignment like this, it's less recommended. But we also have switched Git on. And what we will actually do here, and I'm going to set that up with you, is use one of our Git features where we connect a GitHub template. So what I've set up here is a repository on GitHub, a private one, and then under settings, what I've done is I've made this a template repository. So what I can do now is sort of use the CodeGrade GitHub integration where students start from a template. And then here I would add in like all of the files that student needs, maybe a README. And then what I can do here is connect template repository. And then you can see all of the template repositories in my account once you've connected CodeGrade to your account. And I can simply select this. And now if I submit, this is now the template repo. And I can click on that. And then from the student view, if I create submission and then connect Git, and then you can see I get this view that basically says create a new repository from template. So let's do this. Concurrency, assignment, create repository. And then it will do everything behind the scenes for you. And then it will create one initial submission with the repo. And if I go to my account, I will see a new Git repo that I can then clone into. So let me go to my repositories. So you see there's this new private repository. So nobody else can see this, and this has been generated from this template repo that my teacher has set up. And now on every new commit to the main branch, or if you push to the main branch, a new submission in CodeGrade will be automatically created. So if I simply, let me just create like a random file here using Git, and commit this directly to the main branch. What you will see here now, if I go back in here, just reload, you will see there's now a new submission that has this random file in it. So that's sort of a nice way, especially as you work with more complicated assignments and you want students to use Git. This is a nice way to set it up to ensure they use a specific structure. But let's get into the auto testing for this. So again, the auto testing here is more straightforward in the sense that we're just using unit testing. So if I go to the settings here and then to auto test, you see we have a couple of tests here. Let's go to the setup first. So for this assignment, we've decided to use Clang. And then also here we have a script that does the installation of Google Test. So how I created this is I went to the documentation here and then C++ and then advanced, and we have sort of scripts for these available. So here you will see there's some auto tests set up for Google Test. And before we do that, we have to install CMake, of course, because we're also using that. And to really compile Google Test easily, CMake is the best solution. But yeah, it's basically we're updating, we're installing CMake, then we're cloning into the Google Test repository, CDing into that, CDing into build directory, CMaking everything, making everything, and then installing. And then Google Test is all installed. And if I press build snapshot, you will see this took about 32 seconds to run, but now it's just there and I'm sort of all set up. From my test perspective, again, what we're doing here as a sort of reminder, let me open up the test student. The students are handing in a structure where they have like a CMake file and then a source and a test. And in the tests that they've been provided, they only have some basic tests. So what we're doing is we are inserting some other tests. So I have the blocking tests here that are Google test files. And again, we can do stuff with threads. We do have only one core available, but you still have hybrid threading within that core. So it is still possible to do things like concurrency within CodeGrade. Of course, it's not true parallelization, but it is still threading. And then we have all of these tests, and then we also have a new CMake file that we insert. of course, to add in these tests, but also just to ensure that if students updated their own CMake file, we just override that with our own so we can make sure it always goes correct. Quick question on the setup phase. So for Marius, can teachers pre-install libraries like Google Tests? Can students also access that setup script to set it up on their computer? That's a good question. So this whole setup phase is not available to students. So students cannot see anything here, which is generally, of course, what you probably want. So it's not very interesting for students to know how you set up the auto-grading. And depending on like what kind of operating system students use, these might also not be very related to what they're doing. For Google Tests specifically, what you probably would do in your CMake is just actually fetch Google Tests in here instead of pre-installing it. But again, like if you do like provide students with files, I would probably provide them with like maybe a make file and then a make install step that will set up their computer. So that's probably the best solution, is to add in some kind of make file that you sort of disregard in the code grade perspective, but that will set up their own computer. All right, so then going on to our sort of scripts here. So again, we use a script to compile. In this case, we set up the student directory, so we just copy everything from the uploaded files. So again, we use an upload file block to upload all of these files that will move those into a specific directory called our uploaded files. And we just copy all of the tests to the student's test directory. And then we also move the CMake file into the CMake file of the student. So this will override their own file if it exists, and if they didn't upload it, we'll just move it there. And then finally, we just use CMake to build everything. And this will build the test. If we look at the CMake here, we will see we are creating a executable called DBQ tests for our queue. And then what we can do here is, when we're actually doing this into a build directory, we can use the code grade custom test to actually execute these. So what you see here, if I build snapshot, the test here, we get this nice sort of code grade UI around the test instead of just text. And that's because we're using the custom test has some features to be able to give this sort of unit test output. So what you see here is we run the test executable, and then we use this Google test output option to output stuff to JSON. And this will create a JSON file with the details of the execution of the tests. And then we basically have a little bit of a bash statement to make sure, to check the exit code here. And if the test executed correctly, we use this specific CGG test command, which is a code grade command, which, let me just show you what it does. So within code grade, there's a hidden CG command. So if I just do cg-help, -help, you will see what it does. So here, this is basically the code grade command utilities that you can use in Autotest. And you can see there's a bunch of commands available that we've made to make things like Google Tests easier. Also, this is the command that a lot of these blocks actually use behind the scenes. So you will see we have a JUnit 5 block. It will actually use the infrastructure that's provided by this command to do things. So we have a gtest in here. And then, again, we have here the help here, the utility to parse this. And then this basically has one command called parse that you give JSON output, and it will make this code grade auto test. We call this structured output. So we'll provide that UI to the students. So that's basically what we're doing here, is we're parsing in the detail of the JSON file. And that's all we need to do. It will automatically assign the points and all of those things. and it will just sort of work out of the box. A couple of questions. Do you support outputs from other testing frameworks like Catch2, DocTest? Yeah, so let me show you Catch2. So I think we have a community library item for this. Yes, this one. So right here, this is a Catch2 example. So Catch2 is in a sense a little bit easier than Google Test. You just upload like the Catch header file. And for the people unaware, Catch2 is another unit testing framework. So you upload this, then you upload some kind of make file that creates like a executable. And again, this is available from the community library. And then I have my actual test here with my test cases. And then in the test right here, if we go all the way down, this is where we compile the test. We just use playing in this case again. And then also Catch provides an option to output things as JUnit XMLs. JUnit XML is sort of a unit testing framework output that's of course used by JUnit, but a lot of other testing frameworks use this. And then again, in the CG command, we have a option called JUnit XML that you can throw in a JUnit, and then it will just provide sort of the same kind of output. So that's also a good option. Generally, if you have any sort of custom framework, they typically provide a way of providing either some kind of JSON output or a JUnit XML output. And you can parse those into the CG command to get the output. Nice. Question from Tilo: do you have documentation on the CG command? That's a great question. So we don't have like an overview page currently of the CG command, which we should probably do. So we'll work on that. But another way you can sort of, in the meantime, work with it is just like run it in a script log with help, and then you'll find all the options. But we'll make a documentation page for the CG command as well, so you can find out some more information about how to use it. Going back to my other assignment, yeah, so we just run this, and that's sort of all we have to do. All right. That sort of wraps up sort of Google Test and sort of C++ unit testing. Finally, assembly. I have an x86 assembly assignment, and if I go into the description, and again, Fibonacci, but it's assembly, so it's a little bit more complicated. Here we give students a C code for reference, and some information about what kind of conventions we're using, and they basically have to write this into assembly code. So let me go into the submission and then go into the test student to show you the solution. So this is the code that the students have to write. So, of course, assembly so hard to read, but that's basically what it does. And then here in the auto test, again, we have some compilation, and then we actually use input-output testing in this assignment as well with this assembly. But then also we use some unit testing to do some sort of semantics about the code. So in this case, we don't want students to just, we want them to write sort of okay code. So we check the number of instructions they use to see how efficient they can write it. And then also count the number of jump instructions they use so they can't, jump all over the place constantly. And then finally, we do some efficiency. So only if the student's code took less than 0.05 seconds to run, this passes. Of course, important if you're teaching students about assembly, you probably want to teach something about like efficiency and making sort of nice assembly code. So how this works from a auto test perspective, again, here we do allow students to also use the editor. And in this case, I guess we just give them the solution. should change that. But here in the auto test, again, the setup. In this case, we install NASM here for the assembly stuff, and then we have actually two helper files in C that we use. So we have this file that basically handles the input-output stuff of the program, and it basically, we compile this with the assembly file they use, and the student code will fill in this function with assembly code, and then we can actually, this just is the IO wrapper around it, so we can actually use the input-output test. And then we have a C file again that we compile with the assembly that the students use that will do this, and we have just some C code that will calculate the execution time of a program. So again, we have so much max time we have, and then we just use we clock to begin and to end it, and then we just calculate the time. Of course, we could improve this slightly by just doing this in like a for loop or a while loop to do this many times to sort of calculate an average. But here the time is pretty high, so it's okay. And then finally, so the complicated part about assembly here is just the compilation part of it. And what we actually do here as well is, if we have a compilation error, we use again a CG command here to place comments directly in the code. So let me quickly show you how that works, and then we'll go over how this works. So if I go in here, and then I try to make an error, let me just see if this works. It's pretty hard to make compilation errors in assembly. And then, yeah. All right, so here you can see now we get a compilation error, and it sort of shows us in the code itself with the warning. And of course, this is not a valid instruction. So how we do that is as follows. We go to the auto test functionality. And of course, we compile it with NASM. And then what we do as well is we pipe this through CG comments, which is basically an interface similar to the unit testing that will interpret the output of this and puts that through a regular expression. And then give those comments in the code. So we're basically expecting like a file name, colon, line number, colon, severity, colon, message. And we're parsing that into what CodeGrade understands. So from the file, it knows where to place it on the line, on which line to place it. And then you have a severity, where if it's a warning, you can deduct several points, or if it's an error, you can deduct other types of points. And we all set that to 100 for errors. And then finally, compile the helper into this as well. So we just use GCC here to compile the helpers into the compiled submission file. And then finally, we can now, this creates an executable IO test that we can simply use to do IO testing. And then for the efficiency, yeah, we're using the execution time that we compile, and then we run that. And then finally, we actually use PyTest here to do some structure testing. So of course, things like semgrep, they're not really available. So the code structure test is not really available for assembly. But for assembly, like we can use some like regular expressions to check like number of instructions. And to make our life easy, we just drag and drop in a PyTest, because writing Python unit tests is generally pretty easy. So here we just have a specific regular expression. We open up the raw text and we just find all of the matches and then just count that. So this is sort of a easy way of counting specific. So here we have a maximum of 30 of these kind of instructions, and similar, we can only have 2 jump instructions. And then again, with PyTest, we can easily give some feedback to the students. Of course, in other languages, for Python, there's often some kind of abstract syntax tree parser, some parser available for a language, and then you can use PyTest pretty easily to do things like code structure tests that are a bit more involved than what you can just do with SemGrep. All right, so that sort of wraps up the assembly portion of this webinar. I understand we went through, some complicated things and maybe some simpler things as well. But I mainly hope this sort of gives you some ideas on how to grade. Of course, you probably are not able to copy this one-to-one, but I hope this gives you a bit better insights of the things you can do with Autotest, and also some of the more creative ways you can use the blocks to sort of set up testing harnesses that sort of work for you. So are there any questions at this point? All right. If there are not any questions, all these assignments will be available in the community library shortly. So this one is already available, and the simple C assignment is also available. The concurrency one will be available within the next day or so. One question quickly: any plans to connect SemGrep with CG Commons? That's a great idea. I think the infrastructure for SemGrep is a little bit difficult there, but we'll definitely look into it, and I'll make a feature request for that. Again, quickly, we have a public roadmap available as well. So as we get feature requests, we'll add it into this as well. But yeah, it would be nice to get some nicer feedback from SemGrep too. So for now, I want to thank everyone for joining today. We'll send over the recording, and a blog post will also be available within the next day or so as well.